This is Danny Tang doing the probability and stochastic homework for problem 2. It says draw y equals g of x correctly. So this equation has 4 different parts and you have to draw them out separately. So you just draw this on a regular Cartesian coordinate. Okay, so first part, it says y equals 1 when x is less than 0. So since this is non-inclusive, you draw an open circle, and then y equals 0 when x is greater or equal to 0 but smaller than 1. So this is closed circle, open at 1, close at 0, open at 1. And then it says it's negative x from x is greater than 1 but smaller than 2. And this is inclusive. So you just draw this from 1 to 2 when y is 1 to 2. And then it is it is negative 2. Sorry. Negative 2 for when x is greater than 2. So then you just draw a line to the right. So that's how you draw the g of x graph. And then it asks us to find the small fyy, big f of y, in terms of f of x of x. So it would be easier to turn this graph to the side, and what you get for big f of y, you get it's 1 when y is greater than 1, greater or equal to 1. And you can see that the bounds for this graph is y equals 1 to y equals negative 2. So it's 0 at y smaller or equal to negative 2, because this has to add up to 1. And then y of x is negative x for y is greater than negative 2 but smaller than negative 1. And then you find the small fy of y. So this one you would actually have to really turn the graph around, but you can also do it like this. So at y equals 1, there's an impulse function for wherever there's a jump. So for this graph, there are 3 impulse functions: 1, 2, 3. And so at y equals 1, it is f of x at 0 times the impulse of y minus 1, because it is shifted to 1. And then the second impulse function is here, so it's f of x of 1 minus f of x of 0 times impulse at y. This is y at 0. And then for this segment, it's just small f of x of negative x, or positive x, it doesn't matter. From y is greater than negative 2 but smaller than negative 1. And then the last impulse function is at y equals negative 2. So since it's it only exists for x is greater than 2, you have to write 1 minus f of x at 2 times impulse of shifted to negative 2 here. So y equals negative 2. And to draw these two functions, first it'll be easier to draw the small f of y. So small f of y negative 1, negative 2, 0, 1, 2. So 3 impulses, 1 at negative 2, 1 at 0, and 1 at 1. And then from negative 2 to 1, it's the f of x, small f of x, and the professor actually gives us the small f of x here, so you can see that from -2 to 1, this is just an approximation. It's a slope, it's a curved slope that goes up. So in terms of f of x, this is what it looks like, and then it's 0 here, and then that's it. So to draw the big F of y, you basically look at the small f of y, and so jump here, and then the curved function 0, and then another jump, and then 0, and another jump, and that's the same when it goes to infinity. So that's what it looks like.